In this video, we're going to talk about 9.2 Objective 1, where we define concepts related to hypothesis tests for population means. First, let's briefly describe what each of the variables n, x bar, s, sigma, and mu represent in hypothesis tests of a claim made about a population mean. First, the variable n represents the sample size. X bar represents the sample mean. So that's B. S represents the standard deviation of the sample. So that's A. Sigma represents the standard deviation of the population. That's C. And mu represents the mean of the claimed mean of the population. That's D. I'm testing a claim about a population mean. What is a standard score for the sample mean? A standard score for the sample mean is going to usually be a z-score from the standard normal distribution. There's other hypothesis tests that we can use t-scores for, but usually we're going to be using z-scores. What is meant by critical values for significance in a hypothesis test for the population mean, and how are critical values used for making decisions about hypothesis tests. So the critical value are the standard scores required for statistical significance at a given level, such as the 0.05 or 0.01 level of significance, which is A. And there's usually a chart in the textbook that tells you what those critical Z values are. And you can always use your calculator to help you find those. I showed you how to do that in a previous video, but the main one that we're going to be using, since we like 95% confidence intervals or alpha of 0.05, is going to be that our critical Z value, if C is equal to 0.95, is going to be plus or minus, depending on which side we're on, 1.96. It's going to be the main one that we're going to be using. But there's going to be other considerations, such as, is it a two-tailed test or a one-tailed test, and so on, that help us choose the correct level of, or the correct critical value. How are critical values used in making decisions about hypothesis tests? They determine our rejection region. So the standard score can be compared to the critical values given the standard normal tables or by technology. Lots of times we draw a picture and say that our critical Z value is here, and then we have a rejection region that gets made from that, and then we test to see if our test statistic Z falls in there in the rejection region, and if so, we reject H naught, or if it falls somewhere in here not in the rejection region, then we fail to reject H naught. So we usually write a rule for how to make a decision. What is a type 1 error and what is a type 2 error? Really important concept here because alpha tries to remove type 1 errors. Beta, which we don't talk about in this textbook, it's not an introductory thing, is another type of, is the probability of committing a type 2 error. And our type 1 error is going to be the mistake of rejecting the null hypothesis when the null hypothesis is actually true. And a type 2 error is the mistake of failing to reject the null hypothesis when the null hypothesis is actually false. we consider to be usually, not always, but usually we consider a type 1 error to be the more egregious error to make. So we try and minimize that and make alpha as small as possible. And we cannot get alpha and beta to both be small. We have to pick one of them to be small, and that's going to automatically make the other one big. So you have to pick which one is more important to you, to eliminate the probability of a type 1 error or to eliminate the probability of a type 2 error. And that's given in the scenario, which is the worst situation, to reject the null hypothesis when it's actually true, or to fail to reject the null hypothesis when it's actually false. Okay, that's it for this video. We'll come back next time and talk about 9.2 Objective 2. See you for the next video.